Okay, so here we go. So we're in, what section are we in? We're in 8.5. 8.5, this is problem number 10. All right, hey, so let me show you how to do this. So problem number 10 is saying 3, 60. 3, 60. So you just turn to the 60-degree angle, which is this one, right? So you just turn the cannon to 60 degrees. Everybody see what I'm doing there? I just turn the cannon, right? Aiming at 60 degrees, and then I'm going to shoot out. Those are radial lines. Each of those lines is 1 unit out as we go. Those are, this is a circle of radius 1, radius 2, radius 3, radius 4. See what I'm talking about? So convenient. We're supposed to go out 3. So I'm going to shoot out a distance of 3 along that line. So 1, 2, 3 right there. There's the dot 3, 60. It's that one dot. Does that make sense? On that, we good? All right, let's try another one. Let's see. Let's do question number. That's the same thing. That's the same thing. What if they give me? How about if they give me 2, -40? So number 14. So I'm looking at number 14 here. This is, again, section 8.5. And we're talking about 2, -140. No, sorry, -240. 2, -240. Can you find that dot? Find that dot in polar coordinates. So you got to find you got to turn the cannon to face -240 degrees. First off. So how would the cannon face -240? This is -90, -180. This would be -270. So -240 would be right there. Just kind of missed that a little bit. It's that line right there. Okay, is that good? That's where we're going to aim the cannon. So everybody see how I found that? It's almost to -270, isn't it? It's just 30 degrees off. Oh, no, I'm sorry. I better look closer at my polar paper. Did you see where I'm off? It's supposed to be right here. It's that one. It's the same as 120, isn't it? 240 and 120 make 360. That's how I know. They're putting extra marks. They're doing every 15 degrees. This is 9, that's 15, 30. See how 90 to 120, that's the 30 right there? Everybody tracking with me? See how that is? So there that is. So I'm sure you can find that. I don't know exactly where I found that. Polar, but it's a very convenient kind of polar paper. I'm sure you can search around. Print that out for your homework if you want. Okay, so there's -240, and now we shoot out. How far do we shoot? 2. So 1, 2, right there. There's the point. Aim the cannon at -240, shoot out 2 radial distance. So it's a different system for finding dots on the graph. Good? Questions on that? Okay. I'm going to move on. If you're good, let's do one more where they give us radians. How about if they go? I haven't made this negative. Yeah, let's do this. Let's do number 15, which has -3, 45 degrees. -3, 45 degrees. Now, let's turn to 45. So first off, turn the cannon to 45 degrees. So that's this line right here. Right? Turn the cannon to 45 degrees. All right, and then I shoot out. How far do I shoot? That's a weird thing. -3. How do you shoot out -3? It's a backfire. It's like the cannon backfiring. So you're aiming the cannon this way, right? And then it backfires 3. So you go backwards on that line. Now, what's backwards from that line? You got to kind of trace it backwards. I'm having a little trouble telling. It's right in the middle. It's right here, huh? It's going to backfire 3. 1, 2, 3, right there. There is the dot. -3, 45. So you turn the cannon, you aim at 45 degrees, and it backfires 3. It backfires 3. Is what happens on that. So there's the dot. Making sense? Questions on that? All right. And let's do maybe one more of these, if you're okay with that. And this would be number, how about number 20, which is -2, 3 pi over 2. Can you find that one? So turn the cannon to 3 pi over 2. We come up here on break in a few minutes. I can even photocopy. There's only 7 of you. I can photocopy a few sheets of this real quick. -2, 3 pi over 2. So you turn the cannon. Here's 3 pi over 2. You see it down there? So you turn the cannon. The cannon starts, that's 0, right? That's where it starts. So you turn the cannon to aiming down this way at 3 pi over 2. And then how far am I going to shoot along that line? Here's the cannon. The cannon's at the origin. You're aiming down, but it's going to backfire. You understand what the backfire is? So whatever direction you're aiming, so the cannon is aiming down, but it's going to backfire 2. So it's going to go 1, 2, right there is the point. Is that making sense, how to locate those? Could we say that same dot in the other system, the system we're used to, the rectangular system? What is that location? You know, there's x, comma, y. What is that dot in the normal system? Same location. So this is a military operation. You're trying to locate where the enemy is. Where are they? Well, they're at -3 pi over 2, aim the cannon, -2, that dot. But how can you say it in terms of over and up? X and Y. How far, starting from the origin, how far over? How far sideways? Over 0, up 2, huh? So that makes sense. That's the same thing as 0, 2 in the rectangular system. It's -2, 3 pi over 2 in the polar system. By the way, there's other ways you could say it. How else could we say it in the polar system? Couldn't we just turn the cannon to facing straight up and shoot straight ahead instead of backfiring? Instead of aiming down and backfiring? We could, huh? That's another way. You could just say, look, aim straight up, which is pi over 2, and just shoot 2. That's going to be the same location as well. We have 3 ways of saying that same dot right now on the screen. You all see that? You could just say, look, just aim at pi over 2 straight up and shoot 2 up. That'll land you right here. Or, the original way they gave me, aim down and backfire 2. Or rectangular, over 0, up 2. Those are all different ways of saying that same dot. You see how these work? Just different systems of locating a dot on that. All right, let's move ahead. Just a couple minutes to the break. Let's move ahead here. For each ordered pair, give their ordered pairs with theta between -2, 16, +2. What's that? 121. For each ordered pair, give 3 other ordered pairs. Okay, I'm going to move on to that because I'm going to copy you some paper at the break, and we'll do that the break. Let's move on to 27. We'll come back to those when we have some paper. 27. Convert to rectangular. Use exact values. Okay. 2, 60 degrees. So I'm going to take that, and they want me to convert to rectangular. They want me to convert that to rectangular. So how are we going to do that? We're going to use the formulas they give us, which is x equals r cos theta and y equals r sine theta. So we're going to convert from r theta to xy. We're going to convert between the two systems now. How do you go between a polar location and a rectangular? We'll use those two conversion formulas, which is just what we were using before, isn't it? X equals r cos theta. I'll show you in a minute where those come from. Let's just crank one out. Well, I guess I could show it good enough. If you have some location that you turn to angle theta out distance r, right? If this is the point, r comma theta, that means you turned to an angle theta and shot out a distance r. So how did they come up with the xy? If you make a right triangle, that's how you get the xy. Does everybody see what I'm doing there? Because xy coordinates are straight over, straight up. That's why it's a right triangle. That's why it's a right angle. Because rectangular is straight over, straight up. How could you find the xy there? Well, you can tell if you take the cosine of theta. Remember SOHCAHTOA? Do you guys use SOHCAHTOA? You know what I'm talking about? Yeah, SOHCAHTOA. If you use SOHCAHTOA. Cosine is adjacent. So if this is the angle, theta right here, right there, then this is the adjacent side, the hypotenuse, the opposite side. So cosine is adjacent over hypotenuse. It's x over r. So cosine is x over r. Do you see how they came up with the formula then? X is r cos theta. Then they just multiply both sides by r. Right? If I multiply both sides by r now, boom, x is r cos theta. That's how they came up with that formula. I'm just showing you where it came up, where they came up with it. That's how you convert. So anyway, if that all, I hope I didn't confuse you. That, you do not have to do that. That was all background noise. That was how they came up with this formula. All we have to do is use it. So x equals r cos theta, y equals r sine theta. Here we go. To find x, you take the r, 2, times the cosine of the angle, 60 degrees. Good there. So x is 2. Do you guys just have cosine 60 memorized? What's cosine 60? Does that work for you? I want to draw you in a circle, but I won't make you do everything new. I'm not your main teacher here. Y equals r sine theta. 2 sine 60. What's the sine of 60? You all know that, root 3 over 2. So these 2's cancel, root 3. So there we go. 1 comma root 3. What did we do? We converted from polar coordinate to rectangular. All this triangle stuff on the side is not needed. That was just me showing you where the formulas came from. All you have to do is x is r cos theta, y is r sine theta. Is that good? Questions I can answer on that? Why don't we do one more and we'll take our break? That was 27. Let's just try, let's try 29, how about? Which is 3 comma 3 pi over 2, convert to rectangular. So use the formula x is r cos theta, y is r sine theta. Can you do that real quick? So x equals r is 3. Theta is 3 pi over 2. So 3 cos 3 pi over 2. And what's the cosine? How are you with cosine of 3 pi over 2? Let me show you what I do. Oops. I have a unit circle always right here. We go. I was just doing this with my pre-calc students like yesterday. There's the unit circle. I just must have one of those. 3 pi over 2 is right here. Cosine, sine. Remember the x-coordinate is cosine, the y-coordinate is sine. It's that dot right there. 3 pi over 2 is right there. So cosine is 0. See it right here? Cosine is 0, sine is -1. So the cosine is 0. 3 times 0, x is 0. Y equals r sine theta, 3 sine 3 pi over 2. Looking at the unit circle, the sine is -1. So 3 times -1, and 3, so that's 0, -3. That's the same location. That's the same dot given in a different coordinate system. Was that good? How many got that? How we do? I just want to know if I should speed up or slow down. So about half of you got that? So on your own before I got it? Is there something I can say to help with that? That's pretty good. About half are getting it. I assume the other half were getting there, and I just raced ahead of you. Any questions I can answer on that? See how we're doing that to convert? All right, why don't we take our break? It's our 10-minute break time, right? Take our 10-minute break. Is what'll be there. Okay, so let's backtrack. We skipped. What did we skip? We skipped number 21. Okay, so going back to 21, they're giving me 260, and then they say for each ordered pair, give 3 other ordered pairs, which is the same point. Basically, they want to say, hey, can you find the same point other ways? So let's find 260 first off. Let's do the polar coordinate thing and find 260. So that means turn the cannon to 60 degrees, which is right there. So turn the cannon to 60 degrees and fire out 2. So boom, right there. On our polar deal. So now, can you find that dot and write it different ways? I don't mean rectangular. I mean still using polar. Like, what's another way? What's another way we could turn the cannon and fire somehow with different numbers, but really end up at the same dot, same location? How else could we get there? They want us to do 3 other ways. How else could we do it? One more time? Yeah, let's do a negative, yeah. So yeah, if instead you'd go negative 300, right? Negative 300. Yeah, that's the same as positive 60, isn't it? So yeah, so we could say, okay, look, that's the same as 2, negative 300. Good job. That's the same dot, isn't it? Just turn the cannon negative 300 degrees. It's the same as positive 60. Because together they make 360. So together they're aiming at the same point, don't they? Everybody see that? What's another one? Yeah. So aim the cannon this way. Aim at the opposite of 60 is 240. Yeah, aim it this way, 240. So turn the cannon. Let me get rid of this one. Turn the cannon to 240 degrees, and then backfire 2. Right. Excuse me. Excuse me again. Negative 2, 240. That'll do it, huh? Right? Aim the cannon at 240 and then backfire 2. How about one more? Negative what?
Negative 2, negative 60.
Negative 2.
And negative 60 degrees.
Oh, yeah, negative 6, or negative 60. I think we'd want to go, this is going to be a little bit more than 60, right, because it's past 90. Yeah, so this thing, yeah, let's do this angle. You're right, though. Let's do a negative angle. Let's go to here and then backfire 2. But how do you find that negative angle? It's more than 90, right? That's more than 90. It's 90 here and 30 here. Yeah, it's negative 120 and then backfire 2. Does everybody see how negative 120 is the same? Yeah, if you're wondering, if you're having a little trouble with negative angles, the way to find negative angles is they have to add to the positive angle to be 360, don't they? So this has to be negative 120. This has to be negative 120 degrees plus 240 makes 360. Everybody see that? Because to get right, because if you go 240 and 120 together, that's the whole circle. Together, that's 360. So if you're wondering what a negative angle is, just subtract from 360. So if you're looking, say, well, I want to go right here at this 240, but I want to do it negative. We'll take 240, take away from 360. That'd be 120, negative 120. Yeah, so there we go. There's 3 other ways to indicate the exact same angle. So how did we do it? We pointed in the opposite direction by 240 and by negative 120 and backfired 2. And then the other one was, and then we just went negative angle all the way to that dot, negative 300. Good. So there's lots of ways to do that. Let's move on. What other one were we just working on? We did 27 and 28, right? We converted, so we're done with that. Use your graphing calculator to convert to rectangular, round all values. Yeah, so if they give you, it's like on 35, they give you 2, 19 degrees. And they say convert to rectangular. You know, those X, Y. So they just want you to use your calculator. That's what they say on these. So you guys know the formula. X is R cos theta. Y is R sine theta. So just hit the buttons on your calculator. R is 2 cos 19 degrees. I have my calculator here. Do you guys do these kind of on the test? Do you have calculator problems sometimes like this? Okay, so 2. Oh, you got to make sure you're in the right mode, right? This is degree. I'm in radian right now. Okay, there we go. 2 cos 19. I'm getting 1.89. How far do they want me to round? Four places. 1.8910. And y is 2 sine 19. I'm getting 0.6511. So there we go. 1.8910, 0.6511. X, Y, I converted to rectangular. All right. Let's go the other way. Now we're going to convert to polar, which there's different ways to do it. What's the earliest? To convert to polar. Yeah, I like that way too. Where the sign of R and the choice to place as X, Y. Yeah, I agree. Okay, so let's do it. So now we're going to do question number 39, and they're going to give me negative 3, 3. This is X, Y, and they're going to say convert to polar. So now we're going back and forth between the two systems. So now we're going rectangular to polar. How do we do that? Well, the formulas for that, R is going to be plus or minus the square root of x squared plus y squared. Remember, and then why the plus or minus? You pick the correct sign based on the graph. Sometimes it's plus, sometimes it's minus. I'll show you. That's how we get R. And the theta, the tangent of theta, is y over x. Remember how tangent is sine over cosine? It's y over x. I feel funny giving you those formulas and not showing you why. Remember, it's all because if you're at some point xy. You don't have to know this, but I feel funny not giving you a good reason why. So ignore this if you want to. Ignore this right now. But here's how they came up with those formulas. If you're at some dot over x up y, then you could make a little right triangle there, couldn't you? Over x up y. This would be r, and Pythagorean theorem would tell you r is the square root of x squared plus y squared. And this angle theta here, see how the tangent would be y over x? That's how they came up with that conversion stuff. Okay, anyway, you don't have to do that. Let's just crank it out. Here we go. So these are the formulas you want to memorize for the exam on Tuesday. Your test, will it cover this section? It will, huh? It's all Chapter 8. So make sure you memorize these formulas for your exam on Tuesday. All right, here we go. I would suggest you actually graph it because we need to pick the plus or minus based on the graph. So where is this point on the graph? Back 3, up 3. Back 3, up 3. Boom, right there. There's the actual dot. Good. So now I want to find the angle theta and the r that'll shoot out to that same dot. So what is r? Square root of x squared plus y squared minus 3 squared plus 3 squared. R is 9 plus 9, square root of 18. Remember how to simplify the square root of 18? How do we simplify the square root of 18? What is it? Yeah, exactly. Y'all remember that? So it's 2 times 9. 9 is 3 times 3. 2 3's in, 1 3 out. Or you could just say, yeah, probably confuse you. 2 times 9, square root of 9 is 3. So it's 3 root 2. 3 root 2. So there's our r. Now let's find our tangent theta. So the tangent of theta is y over x. It's the y over the x. It's 3 over minus 3. So tangent of theta is negative 1. Where is tangent negative 1? How do you guys do it? Again, I would just go to the unit circle when I teach trig. I feel funny teaching trig without unit circles. That's why I always hesitate here, because I would just go to the unit circle. But what do you guys, just like know it cold? Do you guys know that one? Just bang. I just know that one. I'm just a walking, memorized tangent of theta. When it's negative 1, it's boom. Do you know that?
Well,
what do you do?
We get tangent to equal 1, and then we find it on the quadrant to equal negative 1.
Oh, good. Yeah. So where's tangent 1? Okay, good way. Okay, where's tangent 1 then? 45. Everybody good with that? 45 degrees tangent is 1? And then where is it negative, huh? Yeah, right? Is everybody good with that? I'm just hearing from one person. I want to make sure that everybody is good with that, because this always makes me. I would do the unit circle again. I don't know if I'm bugging you or helping you. I just keep showing that unit circle. If you look on that unit circle, tangent is going to be negative 1. Yeah, it's going to be right here, because this is cosine, this is sine. It's where they're the same, huh? It's where cosine and sine are the same, because tangent is sine over cosine, isn't it? So it's where they're the same, but one of them is negative. It's right there, 3 pi over 4. Yeah, so that angle is 135 degrees, because tangent, you can see we're in the second quadrant, huh? And so that angle is 135. So there we go. So what's the answer then? 3 root 2, 135 degrees. We converted from rectangular to polar. It's the same dot. If you turn the cannon 135 degrees and you shoot out a distance 3 root 2, you'll end up at the same dot as if you go back 3, up 3. So everybody seeing that? Same exact location. So you want to memorize those two formulas. Let's try one of these. Let's try, how about number 42? Minus 2 root 3, comma 2. All right, so convert to polar. So you got to use the formulas. R is plus or minus the square root of x squared plus y squared. And tangent of theta is y over x. Hey, do you guys have homework in 8.6? Can I hear what those are, what those problems are? Because I'm a little confused by Miss Wynn's note to me now. What are they in 8.6? What's the actual homework problems?
55 to 65.
One more time? 55 to 65 odd. 55 to 65 odd. That's it in 8.6, huh? Convert each equation to polar coordinates and then sketch the graph. 55 to 65 odd. Okay, we'll do that. All right, how y'all doing? So the r here will equal the square root. It's plus or minus square root of x squared minus 2 root 3 squared plus y squared. Okay, plus or minus. Okay, so how are you with negative 2 root 3, negative 2 root 3? Do you know how to square? Here, let me just square it. So to square that, you square the 2, which is 4, and the root 3 is a plane 3. Plus 4. 12 plus 4 is 16. Plus or minus 4. Good so far? Did I go too quick on that? You okay with that? Everybody see? Right, I squared that negative 2 root 3. Right, I squared the 2. 2 squared is 4. And root 3 squared is just plane 3. Just removes the root. Is that okay? Let's see what happened there. So it's 12 plus 4 is 16. And the square root of 16 is 4. We'll decide the plus or minus based on the graph. Let's do the tangent part of the deal. Tangent of theta is y over x, so y over x. This is x, this is y. So 2 over minus 2 root 3. So tangent of theta is minus 1 over root 3. Yeah, do you know where that is? You just have that memorized? So where is that? Where does tangent come out 1 over root 3? Because remember, tangent is sine over cosine. That's how I remember. I just think, okay, tangent is sine over cosine. Now, how do you, whenever you see that root 3, you know what that really means? That means this is a half over root 3 over 2, huh? But those 2's canceled, top and bottom. You with me? Remember, it's all about the small, medium, large. The half, root 2 over 2, root 3 over 2. It's all about those 3 numbers, isn't it? So when I look at 1 over root 3, I think, oh, that's really a half over root 3 over 2, and the 2's have been canceled. Top and bottom. If you just multiply 2 top and bottom, it cancels out both those 2's. So, okay, so what? Well, where is the sine a half and the cosine root 3 over 2? Yeah, so, well, see, I'm drawing the unit circle. So I just think, where's the sine? Sines and yeah, there's actually 2 places. So, yeah, so it's going to be right. It's going to be right here. Sine's a half. So it's going to be at 150 degrees, exactly. At 150, do you know how to do that? So again, I don't know what to do to help you. I would say unit circle. Unit circle. 100, if you go to the unit circle, I would say, yeah, where is the cosine root 3 over 2 and the sine a half? Right here, cosine sine. Sine's a half, cosine's root 3 over 2. And it's negative over positive. See how it's going to be in that quadrant? It's right there. It's 150 degrees. It's where the sine is only up a small amount. And this is back a large amount. Is that good? Sorry, I feel hamstrung. I don't know what to do to help on that. So you guys just know that. You just know 150? How many know 150? Do you really know 150? It's like half of you know 150. Yeah, it's hard. I just can't reteach all that. I mean, at this point in the course, I have drummed unit circle for like 80 hours, and they know it. So I don't know what to do to help you at that point if you're rusty on that. So yeah, you have to be able to find those angles or you're dead in the water, right? You've absolutely got to be able to find angles for things like that. So if you're having trouble, so to find that, I'd say, okay, so you guys memorize triangles. Is that what you do? And you just say, okay, I know where cosine. Is that what you? I'm sorry, I'm just stumbling. That other way is so repulsive to me because it's just such a raw memory thing. What do? You memorize triangles, and you know really well the half root 3 over 2. Is that what it is? Okay, it's got to help me out here. Tell me what you're doing, what you're thinking, and I'll take you from there to the answer.
I memorized 0 through 90 degrees.
Okay. Based on the sign and what you need, yeah. So you just memorize 0, 30, 45, 60, and of course, yeah, so 30, 45, 60, and you know that the sign, how about that? It goes small, medium, large. This is a 60 here. Like that? Is that what you have memorized?
Yeah.
That's true. That'll work. You guys know that? Yeah, okay, let me just go that way with you. All right, so for sign, just small, medium, large, small, right, 1, 2, 3, right? And then cosine just flips these two, doesn't it? Has root 3 over 2 here and a half down there, and the middle still the middle, no change there, right? Is that how you have it memorized? That's true. That'll work. Okay. And so then you go, okay, so I'm looking at it and say, where's cosine root 3 over 2 and sine a half? Well, it's this, right? No, it's not. It's this. Cosine is root 3 over 2 and sine is a half. It's that one. Now, 30 degrees, yeah, but what quadrant? It's 30-degree reference angle. What does reference angle mean? With reference to what? With reference to the x-axis. Are you clear on that? We've got to be crystal clear. There's a couple things in trig that you cannot be shaky on. And if you get them solid, you can do anything else. All the rest is just small potatoes. If you're really solid on these angles and really solid on reference angles, the rest is just filler. It really is. If you're shaky on those, nothing else will seem to make sense because they constantly use those. So what am I saying? I'm saying you got to know these cold, have these memorized, and then figure out what quadrant. What quadrant are we in? Well, look, this is back and up. So we're back and up. We're in the second quadrant, aren't we? See how I did the XY coordinate here? This is XY, rectangular coordinates. See how I'm back and up? I'm in the second quadrant. So what? Well, where is 30 degrees? I already agreed that's the angle. 30 to the x-axis, right there. 30 off the x. How we doing? So what angle is that from here to there? 150. That's how we come up with that 150. There's a problem there. The pen's having a little issue. Something on the screen there. So that's 150 degrees. Now, one more time. So when you're looking at this question and you're saying tangent of theta is 2 over negative 2 root 3. Let's do that again. Tangent of theta. I know we're using up all of our time, but I won't do you any good if I don't make this solid for you. 2 over negative 2 root 3. So we have this. That's tangent, which reduces to be negative 1 over root 3. You've got to look at that, and you've got to go, oh, okay, sine over cosine. Where's the cosine, the root 3 thing? And then you've got to just know. 30, 45. Yes, let me do it your way. So half, root 2 over 2, root 3 over 2. And you go, okay, where's cosine root 3? And cosine switches these. Cosine's root 3 here and a half there. Where's cosine root 3? It's this one is 30 degrees, but it's a 30-degree reference, which means 30 degrees from the x-axis in the correct quadrant. We already know we're in quadrant 2 because of the coordinates, right? Back here. The coordinates are back and up, aren't they? So we know we're in quadrant 2. So if this angle's 30, see how I went 30 there? And here's the mistake you don't want to make. Don't go 30 there. See how that'd be 30 to the y-axis? That's not a reference angle. Reference angles always hit the x-axis. Are you clear on that? They're always to y. Why? Why the x, not the y? Because we started with 0 degrees at the x. They simply started there. Because they did, all the other angles must be to the x-axis as well, to be the same angle in another quadrant with the same values for sine and cosine and tangent. All right, you don't have to understand all that, but x-axis. That's what you got to be clear of. So whenever you get an answer that you're looking for, 30 degrees, it's off the x-axis in whatever quadrant. So what's 30 off the x-axis? That's really 150, isn't it? So the angle is 150. That's how we know. So we're done with this problem. So what was it? It was plus or minus 4. It's going to be plus 4, right? Because you're going to go out 4 at 150 degrees. So the answer is 4, 150 degrees. You can make the same answer by pointing this way and doing negative 4 is what they're saying. We're not going to do that. Is that good? How are we doing on that? Questions? All right. So let's move on. So there's just more and more of those. We've covered those. So we converted both ways. Convert to polar, convert to rectangular. Let's go to equations. So I'm going to jump to 57 because I'm looking at the time here. 57. They're going to say, okay, let's play with equations. R squared equals 9. Write each. Change to rectangular equation. So now we're going to take a whole equation and change it to xy. They're going to give us r's and thetas, and we're going to change it to x's and y's. Convert to rectangular. You getting the big idea of this chapter, this section? It's converting between xy and r theta. Back and forth between the two systems. Graphically, equations, the whole thing. Okay, so how do we do that? Well, we use those formulas that we already know about. R equals the square root of x squared plus y squared. Tangent theta is y over x. Those two, you want to memorize those two for your exam on Tuesday. Those are the two. And then x equals r cos theta and y equals r sin theta. So those four. Those are the big four. Know those cold. So what I would do, you know what I did when I took exams and I was in your shoes as a college student having a million exams and like I already told you, terrible memory, can't even remember things I did with my sweet wife. I would just memorize like those forms. I'd be saying them, I'd be looking at my notes. Teacher starts passing out the tests, right? Teacher would go, all right, notes away. I'd put away my notes. Within 1 minute, that test would hit my hand and I would write those formulas right at the top of that test. I only had to memorize it for like 1 minute. And I'm playing by the rules. I'm not cheating. I do that rather than like halfway through the test when I might have trouble remembering my name because I'm stressed out about everything else. You know what I mean? Write those right at the top of your test. The minute that test hits your hand. I'll probably be the one passing that out to you next Tuesday. And just write them right at the top, those four formulas. That way you don't have to memorize them all. Maybe you've got a great memory. It's not a problem for you. So, okay. So here we go. Let's convert this thing. What can I do with r squared? What's r squared? I'm sorry. We're changing to xy. Trying to change to xy. So in other words, if I take this little formula right here and I square both sides of it, it tears off that root. So doesn't r squared equals x squared plus y squared? Tracking with me? I just squared both sides of that. So that r squared I can replace with x squared plus y squared equals 9. Done. That's all they want. They just want me to change into xy. That's what they mean by change to rectangular. You tracking with me? Rectangular means xy. Polar means r theta. Write each equation with rectangular. That's all they want. Done. Just change all your r's and thetas to x's and y's. Just change systems. That's all they want on that one. Let's try another one. How about number 59? R equals 6 cos theta. R equals 6 cos theta. Same thing. Change to rectangular coordinates, meaning x, y. So when all is done, they want no more r's, no more thetas, just x and y in numbers. X and y in numbers. So how can I do that? Everybody good with the first one, right? You got to be a little tricky here, but once you've seen all the tricks in these next 12 minutes, you'll have them down. There's just a couple tricks. So the first one, we just recognize r squared is x squared plus y squared, right? Because of the formula. R is the root of x squared plus y squared, so r squared is x squared plus y squared. Now this next one, 6 cos theta, it's almost like this one right here, huh? We'd sort of like to use that one, wouldn't we? X is r cos theta. But I don't have an r here. If this was just r cos theta, if there was just an r there, then I could replace that whole piece and say, hey, you're just x, couldn't I? If there was just an r there, I could make that swap, which is what I want to do. I want to swap out r theta stuff for x, y stuff. But there's not an r there. There's not an r there. This was the original question they gave me. There's no r there. But what could I do to put an r there? Can I just stick an r there? Just say, hey, boom, now there's an r there. No, that would change the problem if you did it to only one side. But if you also do the same thing to both sides, that's okay, right? That's the trick. You got to multiply both sides by r, right? You can multiply both sides of an equation by the same thing. You haven't changed it, right? You with me? Logically, is that making sense? Anytime you want, you can multiply both sides of an equation, right? So I multiply both sides by r. What does that give me? R squared is 6x, because that r cos theta on the right is x. Everybody see why I did that? Wanted to make that right side r cos theta, which is x. And now what is this r squared? I'm almost done. I got to get rid of all the r's. What's r squared? Well, we already know that's x squared plus y squared. So this thing is x squared plus y squared is 6x. Done. What did I do? I got rid of all the r's and thetas, brought in x's and y's. It's the same equation. It's the same relation. It'll generate the same picture. If you were to graph it, it would be the same picture. It's just in the rectangular world now instead of in the r theta world. See the trick there? Got to multiply both sides by r to get an r cos theta. Okay, so that's 59. Let's try 60. How about 60? R equals 6 sine theta. Try that one. You got to convert. Convert to rectangular. So what are we going to do to convert? What's the trick? Multiply both sides by r. Well, how do you know? How are you going to think of this on the test next Tuesday? It's because you're looking at that sine theta thinking, look, I need r sine theta, don't I? If I can just get r sine theta, then that's just all y. I can just replace that whole thing with y. So you go, I got to make this r. Oh, so I got to multiply both sides by r. Then I'll have r squared is 6r sine theta, and that whole r sine theta is y. And r squared is x squared plus y squared. Done. Is that making sense on that? That one good? Okay, and now, so there's just a couple other tricks. That's number 60. 61, let's see. R squared is 4 cos 2 theta. I don't know. I have no idea, honestly. These ones are tricky. You guys remember cosine 2 theta, what it's equal to? It's a few different things. It's cosine 2 theta is cosine squared theta minus sine squared theta. Isn't that right? Because it's cosine theta plus theta, which is cosine, cosine, sine, sine. Yeah, so that's true. It's also, and sine squared is 1 minus cosine squared. So it's 2 cosine squared minus 1. Just a couple other things it's equal to. Would one of those help me? Cosine squared minus sine squared. And let me think. I'm actually struggling myself here. Let me see. And x equals r cos theta. I'm going to have to look it up in the book, see if there's some trick I'm not thinking of. They probably don't do one this hard, those dogs. I don't know. There's some trick here. Is the answer in the back of the book? Let me see. This is, what section are we in? 8.6. 8.6. This is number 61. No, this is number... 8.6. Oh, no, we're in 8.5, aren't we? We're in 8.5, 61. So the answer is x squared plus y squared. Oh, they want you to... Oh, okay, yeah, that's a trick. Okay, I see it. Well, now that I saw it. All right, here's what they want you to do. This is really tricky. So r squared is 4. Yeah, do you remember that? You got to remember that formula. Cosine of 2 theta is cosine squared minus sine squared. So that is right. That is what we're going to use. Cosine squared minus sine squared. Good so far. Do you remember that? Do you have that formula memorized? That's a pretty hard one. This right here. Cosine 2 theta is cosine squared minus sine squared. It's one of the double angle formulas. All right, so then you've got to take this thing and you've got to... Now here's the other problem. Is... This one's pretty hard. Distribute that. 4 cosine squared minus 4 sine squared. We good to there so far? We see what I'm doing? So you got to know this formula. Because you don't need the other one. Don't worry about that other one I wrote. All you need is cosine of a double angle is cosine squared of the regular angle minus sine squared of the regular angle. See how it was a double angle, 2 theta, and now it's regular theta, but squared? So you got to know that formula. All right, now, so what? I'm still kind of stuck. Remember what we need. Remember what we need here. We need r sine theta or r cosine theta to replace with x or y. We're trying to replace with x or y. So when you look at this, you think, well, if that just had an r squared, if that was 4r squared cos theta, then that's r cos theta, the whole thing squared, x squared. I feel like I'm doing the Charlie Brown teacher for you right now. The wah, 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 wah. Am I coming across? Is anything coming in? Does that make sense? Whenever you have a cos theta or sine theta, you've got to have an r in front. You've got to have an r in front. Or there's no way to replace it with x and y. You seeing that? I'm simply doing replacement here. I'm just looking and going, look, I got to have r cos theta. I can't just have cos theta alone. The formula says r cos theta is what x is. You got to have an r. Well, then what do I do if I don't have an r? You multiply by the r on both sides. In this case, r squared. Why? Because I have cosine squared. So every cosine needs an r. If you have a single cosine, you need one r. You got cosine squared, you need two r's. So I'm going to multiply both sides by r squared. Do you see what I get here? This is r to the fourth is 4r squared cos squared minus 4r squared sine squared. Bring that over here. This is such a difficult problem. R to the fourth, what is that?
X squared plus y.
It's this squared. It's x squared plus y squared, quantity squared, isn't it? You with me? This is x squared plus y squared. Well, I'm getting tired of this problem. This is a long, difficult. I remember this section. These are. Let me take it again from the top. I'm out of room. I'm running out of time. Let me try again. So r squared is 4 cosine 2 theta is cosine squared of regular theta minus sine squared of regular theta. Distribute the 4. And you get this. And then you've got to bring in that r squared on both sides. Why? Because every cosine or sine needs an r next to it, or you can't change it to x or y. So you multiply both sides by r squared, and you get r to the fourth is 4r squared cos squared minus 4r squared sine squared. And then this is x squared. Now I can do my replacement. That's x squared plus y squared quantity squared. Right? Because remember, r squared is x squared plus y squared, so therefore r to the fourth is that squared. Do you see that? And this side is 4x squared, 4y squared. Done. I got rid of all the r's and thetas, changed it to x's and y's. That was a super hard one. Okay, let's try. This will be on YouTube. I got to do a couple more. I'm going to leave you high and dry. These are difficult and long. Okay, I'm going to go to number. How are we doing? Oh, we're just like running out of time like crazy. Okay, let me look at number 65. X plus y is 5. Convert to polar. So now they want me to go the other way. This is much easier. Now we're starting with xy. They want me to change it to r and theta. Remember how we do that? What is x? R cos theta. What is y? R sine theta is 5. Done. So that way is a lot easier. All right, I am out of time. 8-6, I'm sorry. I can't believe I did all that I stinking could to get there. 8-6, you're going to have to look. There's just those few problems. It's the same thing. Like, let me just say this. 8.6, that last section, it's more the same thing. You do not have to graph. Let me mention, no graphing. No graphing needed. Y'all see that? I know you're wanting to go and take off. I got another class too, all the way across campus. But catch that note. On 8.6, the homework will say, graph these, don't do it. That's her note. She told me no graphs. Don't worry about drawing the graphs on 8.6. So in other words, they'll give you a problem like x squared plus y squared is 16. They'll say convert. Yeah, so we've done it. Yeah, good. Okay, we have covered it. It's just more conversion. Since we're not doing the graphs, it's just more of the same. They'll say convert that to r theta. Well, you know that. What is x squared? R squared cos squared. What is y squared? R squared sine squared. Oh, no, actually, let me change it. That's true, but what's x squared plus y squared? What's the whole thing? R squared. Boom, done. That's all you have to do. Don't draw the graph. We did not learn how to graph in polar coordinates. She wrote, no time for that, which I agree. No time for that. So don't do the graphs, right? So on the 5.5 homework, the 8.6 homework, don't do the graphs. Just do the conversions like we just did. So we have covered the different stuff. All right. Thanks for your patience.